In this video, we compare the proposed perception-aware planner with the perception-agnostic planner for multicopters. We first show the indoor experiment. The goal is 4 meters ahead of the vehicle. The perception-agnostic planner flies the vehicle to the goal aggressively. The videos of the depth camera and the monocular camera with VLO features are shown at bottom left. In comparison, the flight with the proposed perception-aware planner is less aggressive, reducing image motion blur and improves the VLO's accuracy. The flight speed is only slightly reduced. We then show the outdoor experiment. In the first environment, there are more visual features on the trees than on the road, and the target position is set to 20 meters ahead of the quadcopter. The perception-agnostic planner flies the vehicle directly to the target. In comparison, the perception-aware planner guides the vehicle close to the feature-rich area, seeing more features at a closer distance to improve the VLO's accuracy. There is almost no motion blur because of bright light on a sunny day, so the flight's aggressiveness is similar to the perception-agnostic planner. In the second environment, the vehicle needs to fly through a small dense forest. The target position is set to 30 meters ahead of the quadcopter. We first show the perception-agnostic planner, which can reach the target avoiding the obstacles. In addition to collision avoidance path planning, the perception-aware planner flies the vehicle close to the VLO features on the ground to improve the VLO's accuracy. The flight is less aggressive than the perception-agnostic planner to reduce motion blur because of darker light on a cloudy day. The flight speed is only slightly reduced.